Good evening, everyone. Welcome to this introductory presentation about Coursevita. Coursevita is an innovative learning platform designed to provide flexible, high-quality education to learners worldwide. Our mission is to make learning accessible and manageable, even for the busiest individuals out there. With a wide range of courses in various fields, there is something here for everyone. Coursevita supports students and professionals globally by delivering top-notch online training in various domains, including data science, data visualization, and data analysis. Our passionate and dedicated team of experts has successfully trained individuals, providing application and industry-oriented learning on trending technologies for free. This approach helps students gain real-world experience, enhancing their skills and improving their placement opportunities. Our objective is to offer application-oriented training for both students and faculty, focusing on hands-on training with the latest technologies. Coursevita aims to bridge the gap between theoretical knowledge and practical application, ensuring our learners are well prepared for the challenges of the modern workforce. Firstly, why should you choose Coursevita? Our courses are designed to fit into your busy schedule with flexible learning options. The bite-sized lessons make it easy to learn on the go, and the downloadable materials ensure you can study offline whenever you have time. Additionally, our industry-recognized certificates can help boost your career prospects. Let's take a look at some of our success stories. Many learners have benefited from Coursevita's programs, with testimonials highlighting significant career advancements and personal growth. These stories demonstrate the real-world impact of our courses and the success of our learners have achieved. 8 out of our learners are pleased with our courses, and they've quoted that people like Nikita Verma and Anvita Chaudhary has quoted that we have a good selection of courses on various topics. They also mentioned about our platform, which is user-friendly and it is also easy to navigate. They found the content quality to be good overall. If people are ready to take the next step in your learning journey, joining Coursevita is so easy. Simply sign up on our website and you'll have access to a wealth of resources. And we often have special offers and discounts, so be sure to check those out on our website and our social media pages as well. Tirunad will be posting our social media handles in the chat box, and you can directly hit a subscribe button or hit the follow button on Instagram and YouTube, so that you'll be able to look at all the updates that we have about the master classes or about the boot camps that we conduct every weekend. So if you need any sort of assistance or if you have any questions related to any queries or something, please don't hesitate to write us at reaches@coursevita.com, or please don't hesitate to reach us out on any of our social media platforms. Thank you for your time, and I hope to see you soon on Coursevita. Over to you, Maitri. Uh, you can start taking the session now.
Sure. Thank you. Good evening, everyone. This is Maithili, data scientist as well as a research scholar. At present, I'm working for a at present, I'm working for as a researcher and also a data scientist in NWB. And I'm happy to share what are all the things that you can do to be a good data scientist and what are all the things that is required to be a good data scientist in the present industry. And we can see some basic things, what is required to be a good data scientist. So the basic thing is you should be good enough in statistics as well. You have to learn the basics, just SQL, and then you have to go with the visualization, and then what are the modeling techniques that is available. So to start your career or to start your work as a data scientist or data analyst, first you have to start with learning of the SQL, and then you have to learn any of the programming languages like Python or R programming, right? So, and then we can later on move on to statistics. So statistics, which is the base for everything. So whatever the models that we are using at present, I hope you all know that all these models were completely have the background of the mathematics, that is statistics. And then you can move on to the next one is the deep learning or else machine learning stuffs. And then you can go on to the visualization tools, whatever the tools that is available like Tableau, Power BI. So this will be the journey if you are starting to opt your career as a data scientist here. And then the basic courses that we are going to see is we are going to start from this SQL, and then we will move on to the statistics. So today the session is about the statistics. I'm going to take only one thing, that is how to say, only we are going to see about the regression models. So this would be the base for any of the statistics that we are going to learn. So whatever we are studying as mathematics here, that everything has been it will be converted into a programming language. Yes, the data science is completely of everything. So you will be starting, you should have a good knowledge about the mathematical background, and then we will be moving on, or we will be converting all these two into a programming language, and later we will be applying for the different applications. So this is a small introduction about how to be choose a or what would be the roadmap if you are going to or willing to be a data scientist. Yes. So the topic that I hope my screen is visible.
Yes, my screen was visible.
So to start with, today we have given the topic of regression analysis. So regression analysis, before going into regression analysis, it is completely statistics. So when we are talking about statistics, the general statistics is about, it is to describe your data or to summarize your data, or else you can say that it is one half, that is organizing, summarizing, or to know about your data. That is one part of statistics. And the next part, what we can do is we can conclude or you can derive some valid conclusion from the given data. So together it is called as statistics. So a way of describing or summarizing your data as well in order to derive some insights from the given data. So for all these things, we are relying on the statistics. So the general category that we are taking as one is descriptive statistics and another one is the inferential statistics. So in descriptive statistics, we can say that measures of dispersion, measures of central tendency. So this will comes in the descriptive statistics. So when it comes to inferential statistics, which means that you are going to derive some meaningful insights from the given data set. So here, whatever I have covered in the slides is purely relevant to the statistics. I will tell you how to relate this statistical stuffs along with the how to combine this with the data science. So how we are using this in the data science. So I will be correlating both the things and I will be telling you, right? So here to start with, I have told you that inferential statistics is all about deriving some conclusion, valid conclusion from your data set. In the same way, we can say that when we are further dividing this inferential statistics, it is oneness of the, what to say, we can say that hypothetical testing and then the regression analysis. So it will be inferential statistics is divided into two things. One is hypothetical testing, and the next one is we call it as a regression analysis, right? So in regression analysis, how this scatter plots and correlation plays a vital role. So when we are talking about any machine learning model, the first thing we need to know about is what is a regression, what is classification, what is supervised learning, what is unsupervised learning, right? So in the same way, when you are talking about any regression thing, so scatter plots, here we can say that the scatter plot is nothing but this is the visualization that we are using in order to know about how your data points are distributed in the data set. So it is not distributed, which means that whether it is lying with the best fit line. Okay, so what is a best fit line? So how you can derive this? So all these things will be discussed in the upcoming slide. So this is a kind of visualization that we are using. And correlation, when you are talking about this correlation, it is going to establish that. So how we are going to check if two variables are present. For example, if we are taking height and weight. So whether they are, what is the strength and the relationship that is existing between these two. Okay, so if you are taking any of the two variables, so what is the strength and the relationship existing between these two variables, it will be included in this, right? So for correlation is mainly for that purpose. So when it is a linear relationship existing between the data, you will be taking two data variable, and between the variable, you are going to check how the strength and the relationship existing between. And also it also provides you the direction of the relationship in the data set, right? So the first one, we can say that if a scatter plot one shows some sort of relationship, so here we are going to use the correlation in order to measure the strength of the linear relationship between the two variables. So apart from this, you can say that so this is the linear relationship when you are talking about, and this is the curvilinear relationship. So your diagram will be when you are plotting with the scatter plots, your diagram will be in the same format. This is in the positive way, and this is in the negative way. Right, and then how we are going to infer the values from the data. So if I'm taking how we are going to infer if there is a strong relationship or if there is no strong relationship between the data, that is weak relationship, or we are going to check whether it is positive relation or else negative relation or no relationship existing between the data. So as I have told you that if one variable, if you see that if you are having one variable, it increases in one direction, the other variable will also be increases in one direction, right? In the same way. Or else if one decreases, the other one will also be decreases. Yes. Or else there could be a possibility that if one increases and the other can get decreased. So what would be the value ranges for this is, it is what -1 to +1. So if you are getting the value of -1, which means that there is a negative relationship. Right? So one increases, the other get decreases. So if it is a positive relationship, one get increased, the other will also get increased. Right? So this is the positive relationship that is existing between the data. And if you are getting the value as 0, which means that there is no relationship existing between the data. So this is how the correlation with values can be done. So first one, if the value is between if it is -1, we can say that as the strong negative, right? So it is going to be the strong negative relationship. So if there is a value lies between -1 to -0.5, right? So -0.1 to -0.5, which means that there is a negative relation. So strongly negative, yes, perfect positive, perfect negative. We need to know about all these things. So if it is a perfect positive, it is going to be +1. If you get the value as +1, it is going to be a perfect positive. And if the value is going to be the -1, it is going to be the perfect negative. And if you are going to tell that there is no relationship existing between the data, then we can tell that the value of correlation will be 0. The same way, when you are using Python for implementing the correlation, there are different correlation metrics that we will be using. Either it could be a Pearson correlation coefficient or Kendall or Spearman. So based on all these have the background of the formulas only. We are implementing all these formulas only. So out of our choice, the same way, there are different distance metrics are available. So just like Manhattan distance or Hamming distance, Euclidean distance. So out of which we can choose anyone. In the same way, here also, we are going to choose out of any correlation coefficient calculation, we are going to use any one of this, right? So in order to establish that if there exists a positive relation or negative relation or no relationship between the variable. So for example, you can say for the positive relation, we can say that height and weight. So if a height of a person increases and the weight of the person also get increases. So this is going to be the positive node, right? So if it is a rainy season, and then the sales of the ice cream will be less. Yes, one get increase and another get decrease. So this would be the negative correlation, right? So if one factor is not at all influencing the another factor, we can say that is a weak relationship, no relationship. Okay, so when we are plotting all those points, you can get the scatter plots in this way. Yes, the left side is going to be the positive relationship, and the next way you can say that it is a weak relationship, which means that the data points are scattered. They are not combined together, they are scattered, and this is called as the weak relationship. And no relationship at all. You don't attain any of the forms in the first diagram, and the next one you can see that there is no relationship. So here your best fit line will be in the center, and the data points will be all around here, right? Any other things has to be discussed from your point of view in correlation? Any other things you need to discuss? So here the correlation coefficient, here we are using rho. And moreover, when we are talking about statistics, it is often we need to know about how to describe or what are the notations that we should use. For example, if you are talking about a population, if you are taking the data set as a whole and if you are working, this is called as in population. And if you are working on that, yes, so you will be using all the one in the caps, right? So capital N, in general, it will be referring to the population. If you are taking a sample or portion of your data set, and if you are working, it is going to be the sample. So whenever you are talking about the sample, you have to mention in the smaller case and other things in the uppercase. So these are all the basic things we need to know when you are talking about the statistics, right? And next one is the sample correlation coefficient. We are going to it is going to be the estimate of rho, and here we are going to measure the strength and the relationship of the samples. So here it is all about the linear relationship we have discussed, right? So as I have already told you that it will be taking it is an unit free, that it does not have any units to describe it, and the ranges it will be taking from -1 and the +1. So when you are taking the value of -1, it is called as the strong perfect negative correlation, and if it is +1, it is going to be the perfect positive correlation. And if it is 0, we can say that there is no correlation existing between the variables. Yes, this is the example that they have given for the reference, right? So this is -1. So when you're talking about the negative correlation, you can see that how the best fit line occurs, right? So it is from the right edge to the left edge it has been. So when it is from the positive, you can see that it is from the intercept is on the X and Y point here. Okay, so this is the perfect example that you can see that how the value get distributed for the correlation. And here we have taken the sample of children of different heights and weights, and we are going to calculate the Pearson correlation coefficient for that. And here you can say that the value gets, the formula is n into summation of xy minus summation of x into summation of y divided by root of n into x square minus summation of x square into y square minus y, right? So you are going to calculate everything separately, and you are going to apply the values for it. So the obtained value is 0.886, which means that it is in the positive range. Okay, so when we are plotting it in the diagram, scatter plot, you can say that you have a value range. These are all the points. And what are all the correlation coefficient is 0.8, which means that there exists a strong positive relationship. It is not perfectly positive, but there exists a strong positive relationship that is between the different variables. So this is how it works. And we move on to the regression analysis. So when you're talking about the regression analysis, we can say that the first point is how we are going to check this is how we are going to derive the regression for any of the given data. So as I have already told you that there will be a dependent variable and independent variable. So if based on the number of hours we study, our score will be right. So if we are talking about the different things, so in the same way when you are talking about the house price prediction, this is one of the common example that we will be using for the linear regression, right? So when you're talking about that, there will be several independent values. So when there is several independent values, I can say that the values will be like what is the where it is gets where the property is located. What is the size of the property? So what is the range of the property, right? So we will be taking different measures, and based on all these measures, we are going to conclude what is the price of the house. So all these, out of all these things, what are all the independent variable present is that the house property, location of the property, and then what else? What is the size of the property and how many BHK? So when you are considering all these factors, this is going to be the independent value, and one dependent value is going to be the house price. Okay, so we are going to conclude the house price based on all these values. So I call that as an independent value, and based on the independent value, I am going to derive the dependent value. Okay, so here the dependent value, we call it as a target value, or what is the value to be predicted, that is y. Okay, so there could be, if there is only one independent value and only one dependent value, then it is called as the simple linear regression. Okay, so if there are multiple independent value and there is only one dependent value, it is if there is a multiple independent value, only one dependent value, it is called as multiple linear regression, right? So when you are talking about the regression analysis, it is completely about how many independent value and how many dependent values are present. So if there is only one independent and only one dependent, it is going to be simple linear regression. And if it is going to be multiple independent value and only one dependent value, it is going to be the multiple linear regression. So this is the basic things that we have to know about the regression analysis. So if there is any changes that we are doing in the independent values, so if there occurs any of the changes in the independent value, it will be it gets affected in your target value also. So based on the changes that we are doing in the independent value, it has an impact in the dependent value. So this is how the continuous values work. So already this is completely for the continuous variable only. So one is going to be the one independent variable and another one is going to be the one dependent variable. Yes, that is going to be simple linear regression. So on what mathematical basis it is going to work is, it takes the equation of straight line. So y is equal to mx plus c. So this is going to be the formula that we are going to use for simple linear regression. So if you are taking y is equal to mx plus c, so m is the slope values. So x is the one dependent value that is going to have an impact on the target values, right? So the relationship between x and y is described by the linear function. And if there is changes in y, it is assumed to be caused by the changes in the x. And what is the random error and the residues? So here we can say that this is going to be the dependent value. That is, y is going to be the target values or the dependent values. And beta naught is going to be the intercept. And beta 1 is going to be the slope coefficient. And x is the independent value that we are taking. So what about the values that we are taking has a good impact or a bad impact? Which means that it is completely on the independent values. Okay, if we are what is an observed value and what is the predicted value, which means that, so if I'm giving you a data set, okay, if this data set, if it has the n number of independent values, okay, and there will be one dependent value. So based on all these independent values, if I'm making some changes, whatever the data set that I'm giving you, it is for training your data. Okay. So if I'm entering a new data for the given data set, it has to predict based on whatever the model that we are giving. So this is the basic working principle of the machine learning model, right? So it will be trained based on whatever the input that we are giving, and we are going to provide the test data. It is going to provide the outcome based on whatever the values or whatever the things that it has trained out from. Okay. So if I'm feeding more data into it, so this is called as an observed value to it. So if there is an observed value, and based on whatever the training or whatever the model that you are passing in, and if you are giving a test data, it has to learn from the training data and it has to respond for the test data. So that is called as the predicted values. Okay, so observed value is whatever you are giving for the training and test, whatever you are giving for the testing, and whatever the outcomes that you get, it is called as the predicted one. Okay, so the random error. So this is called as the residue or random error, which means that what is the deviation or the error rate that occurs when you are working with the regression model, right? And if you are talking about normal distribution, so normal distribution is nothing but if you are taking a data and it has to be eventually in the normal distribution in order to work with the data set, right? So if it has to be in the normal distribution, the value is to be symmetric, right? So it should not be skewed to any of the path. So either it should not be left skewed or right skewed. It should always be symmetric. So if it is symmetric, which means that mean, median, mode, all these values has to be provided in such a way. It should be have the nearby values or exactly the same values. So if that is the case, then we can say that it is, we can say that it is symmetric in nature or normally is distributed. So if we are talking about the salary of a person, right? So if we are talking about the salary of the person and the age of the person, you can say that the age ranges from some 20 to 50, right? So if it is the ranges of ages from 20 to 50 and the salary ranges from 2000 or 20,000 to 1 lakh. So the value ranges, you can see that it is different. So we have to convert everything into the standard form. Yes. So standard form is nothing but you are going to use the standardization, that is z is equal to x minus mu divided by sigma. Right. So if we are using all this standardization technique, which means that all the value gets normally distributed and it will be taking the value ranges so that it would be easy for us to feed into the model, right? So when we are doing the EDA analysis, so the basic thing is that we have to know about what is the size of your data. So what is your data set? What is the size of your data set? And what are all the columns present? What are all the index? So all these values has to be known, right? So apart from this, you have to say that after doing all your description of your data, then you will be going with normalization or standardization. So after doing all these things, you will be feeding that particular data into a model. So after cleaning, pre-processing, right? So when feeding into this model, you have to know that all these error values to be normally distributed for any of the given value x, and the probability distribution of the error. So we can say that it should has the equal variance. So if there is any random values that occurs, then we can say that it comes out of the error terms. And there is no autocorrelations occurs and there is no outlier distortions. So these are all the linear regression assumptions, right? So if there is no outlier distortion, so what is an outlier in sense? So if I'm having a value that is, as I have already told you, that if we are taking the age range from 20 to 50, if there is a value that has been entered in your data set as -1 or -2, or else if it is 1000 or 2000. Okay. So when you're talking about that, what is an outlier in sense? So whatever the value that is not fitted to the given set. So if you are calculating the minimum value, it should obviously take the value as 20 and it should not take it as -1. When I'm describing my data, it should say that it is an outlier value. So if there is any outliers present inside your data set, it will be obviously affecting your result. It will cause some distortion in the result. So in such cases, we have to remove all those outlier values. That is either in the lower fence and the higher fence. We have to remove all those things, and you are going to take the pre-processing has to be done correct in order to feed it to the regression models. So this is the next one, that is the diagrammatical representation of the linear regression. So population linear regression, which we can say that this is the intercept value. So we have taken the values of the dependent value X and the independent value Y. Sorry, dependent value Y and the independent value is X here. Yes, and we are using the formula beta naught, beta 1 plus error rate, which means that this is going to be the observed value and this is going to be the predicted value. So predicted value is nothing but when you are passing the same value as an input during the testing phase, what it is given as an outcome. That is called as the predicted value. What is the observed value is whatever you are giving as a raw data. So it has to be given whatever the value that is fed, that is called as the observed value. So observed value is nothing but what you are giving as an input, and predicted value is nothing but what you got out of this particular machine learning model. Yes, and intercept is beta naught. And the error rate is the difference between the predicted value and the observed value. So what is the deviation that we have seen from the observed value as well the predicted value? It is going to be the random error. So we always the R-square value should be minimal for a best fit line, right? So next one is the slope. So this is the slope value. Yes, M is the slope value, right? So this is how the linear regression will be plotted. So when you're talking about the data set, all these green points are called as the data points. So all these data points should lie within or nearby or closest to this particular best fit line. So whatever the line that it is drawn here, it is called as the best fit line. So your data point should be very much nearer to the best fit line. So which if the value is getting scattered or something, we have to make sure that it should not be in that way. Yes, you are going to change the value for that. You are going to update the values and you are going to pass it to it. Excuse me. And next one is the estimated regression analysis. The same thing, y cap. So where y cap is nothing but what is estimated is what is the predicted values, right? So earlier y is we have taken that as an observed value. This is the predicted value, right? So this is the line provides us an estimate of the population regression line, which means that this is the predicted value of the given data and estimate of the intercept, that is beta naught and beta 1 into X. So if you are talking about the individual random errors, which means that why we don't have that is we are taking that to be the mean values to be the 0. So this is the estimated regression model. and the least square criterion. So when you're talking about least square criterion, first one is you are going, whenever you are talking about this linear regression models, it should always have the uh, minimal square, right? There should be a minimal squared error. So how we are going to obtain all those things? So that is a performance metric. So when you are giving this particular formula, you will be getting some result out of the given formula, right? So we did not know whether all these answers are correct, accurate, or anything. So for that purpose only, we are going with the performance metrics. So when you're talking about the performance metrics, it is like, what to say, completely about minimum squared errors, how to calculate the sum of squared errors, what is the minimum square error, what is the residue. And then when it goes for the classification type, we will be talking about the confusion matrix, right? What is the accuracy, precision, recall, right? So all these are called as the performance metrics, right? So here we should always ensure that there should be a minimum squared errors, right? So y minus y cap is nothing but y is the observed value and y cap is the predicted value. So for the predicted value, with the formula that we have taken is beta naught plus beta 1 into x, the whole square. Yes, the next one is the least square equation. So here we can say that if we are applying after application of the calculation and derivating it, equating it to the 0. So the final observation will be this one, that is B1 is equal to summation of x minus x bar into y minus y bar and summation of x minus x bar the whole square. And it goes on, and we'll be talking about the intercept and the slope value. So when you're talking about the intercept values, that is B naught. So here we have given us B, right? So when you're talking about the intercept value, average value, when it is going to be what would be the value of x is 0, right? So what would be the range of the particular estimated average value of y? So here, if you are not providing all those things, which means that if there is the variability of the dependent value will be left and explained by the independent variables that we have considered. And one more thing is that if there is a change in B, there would be the equal change that you can expect in your predicted value also. So if you have the values to be extended in E, the values in E, the same way you are going to expand the values in that one also. So here the example that has been taken is, if you are going to take what is the average weight of the diet taken and what is the weight gained in month based on the diet that have taken. So the sample value we have taken is for 20 children, what is the weight gained, right? And based on the x value, what is the diet that has been given. So this is going to be, y is going to be the dependent value and x is going to be the independent value. So what is the based on what is the diet taken? So what is the increase in the weight? So when you're talking about this one, there's a continuous variable when you're talking about the continuous variable, and we are going for the regression problem, right? So here, out of all these things, the value that we are deriving is summation of x is going to be 20.35. So for the 20 data, right? So this is summation of y is going to be 16.25 and summation of xy, it is going to be 17.58 and x square is going to be 22.30. So after applying in the formula, we are obtaining the value of beta naught to be 0.16 and B1, that is the slope value is going to be 0.6. Right? Beta naught is the intercept value. So here we can see, right? we are going to apply in this formula. So this is going to be the least square equation. And this is the formula that is obtained for beta naught and beta 1. And here we are going to use the SPSS. In general, we are not going for SPSS. And generally, we are doing all these things in the data science. A simple Python code will do all these things, right? SPSS is a specialized tool for statistics. So when we are going for the regression analysis, you can see what is the beta value, what is the B value, what is the coefficient, what is the standardized value, the standard error that has been obtained. So based on the input, it will be providing you all the values to it. The same thing we are going to apply, we are going to give it in the Python code and we are going to analyze it. And here we can say that here the no children has 0 kg of food per day and so far within the ranges of sizes observed, and 0.16 kg is the portion of the weight gain if it is not explained by the food. So this is the after applying the regression formula, we can infer all these things, right? So what is the weight gained, and then what is the food weight, and we can say that beta 1, so which is going to be which can be told as the average weight of a children. It will be increased by 0.643 for each and every additional 1 kg of food taken each day, right? So this is how the interpretation can be done from the intercept value, that is beta naught. Yes, and we can say the total sum of squares, and total sum of square is the addition of total sum of regression by plus sum of squared error. So we have already seen that the sum of squared and the sum of squared error has to be taken along in order to calculate the total sum of squared values, right? So y minus y bar. So whenever we are using, we should be very careful that y minus y bar is nothing but y bar is the mean value, right? So it is the average value of the dependent variable, and y cap is going to be the estimated value, or we can say that the predicted or target value. Okay, so when you're talking about SST, that is, it is a total sum of squared. So this is y minus y bar the whole square, and which is the summation of sum of square regression and sum of squared errors. So if you are calculating all these things, then you can go with the SST. Yes, so this is the y cap. So this is the average value, and this is the y cap is going to be the observed value, right? So this is SST, that is y minus y bar the whole square, and sum of square errors is y minus y cap the whole square. Sum of square regression is that y cap minus y bar the whole square. So this is the portion of it. So if we are adding these two things, this is going to be the sum of square, total sum of squares. Okay, so it is the combination of sum of square errors and sum of square regression. We are going to combine these two things. And next one is R square error. There should be a minimal R square. So when you are talking about this linear regression, the sum of squared error should be minimum, right? So coefficient of determination, that is R square. So when you are talking about the coefficient of determination, it is the total variation in the dependent variable, and this is going to be explained by the variation in the independent value. So we are going to in some way, we are going to check if there is a variation in the dependent value that is impacted by the independent value. So whenever we are talking, if there is a variation in the dependent value, obviously there should be a variation in the independent value. So that influences the dependent values, right? So the value is given by R square is equal to SSR divided by SSE. That is sum of square explained by the regression and divided by the total sum of square. So the value lies between R square values lies between 0 and 1. So here we can take it as there is a sum of coefficient sum of determination, and R is the simple correlation coefficient. So this is going to be the determination coefficient of determination of value, that is R square. So R square is nothing but SSR by SST. That is sum of square regression divided by total sum of squares. So total sum of squares is nothing but it is total sum of square errors plus total sum of square regression. And F test, here this is called as a pair test. So first one, if you are talking about the F test, we can say that the H naught, that is that is called as a null hypothesis, right? So if we are going to check whether the impact of one variable have, we say that if it is H naught, if there is a significant relationship existing between the dependent variable and independent value. And if you are taking a H1, which is going to be the alternate hypothesis, and it is going to be the contradict of whatever we are taking as the H naught, right? So here the beta value is equal to 0. So here we can say that the reliability of the regression equation, it is measured by the correlation coefficient R, and we are going to check the statistical significance of R and R square using the F test. So F test is nothing but this is one of the hypothesis testing that we are using in the statistics, right? So this is the student test, student t-test and the F-test value. So here you will be taking the significant values and you are going to check what is the degrees of freedom, and further you move on to the proving whether that is null hypothesis or alternate hypothesis, whatever the values that we have taken. So based on some assumptions, we are taking the H naught and H1. So you are going to prove whether based on the critical values and the test statistic value. So if it is greater or lesser, then you are going to decide whether in order to accept it, accept the null hypothesis or reject the null hypothesis. So this is the SPSS output for the regression R. So R square value will be calculated and adjusted R square value, which means that, so the implication is that 81% of the variation in the children's weight increment is explained by the variation in the food that they have taken. So R square values is taken to be 0.81. Yes, and this is the regression value that has been obtained. And what is the residual values and what is the total sum of total value that has been obtained. So DF is nothing but the degrees of freedom. So this is the F values and this is the mean square that is obtained from the given for the regression and residual as well as for the total. So what is the significance of all those things? So this is the ANOVA table that has been taken from the given input. So how many, based on the input values that we will be taking about, so how many independent values are there? That if we are going with any hypothetical testing, we are going to check what would be our input. If there are more than 3 categories or more than 3 independent categories are present or 3 independent groups are present, then we will be taking up the ANOVA test, or else we will be going with the t-test. So if there is an independent categorical values or independent dependent values. So based on all these factors, we are going to choose which type of testing will be the best one. And this is the model summary. And this is the output. So here I have taken the SPSS output and I have demonstrated. In the same way, we are going to implement everything in the in the simple linear regression, and we are going to implement in Python and we are going to take the output. So in order to establish the importance that importance of linear regression, I have taken up this in the statistical part. Okay, so the same thing when we are talking about the data science and its implementation, we can say that, so what is a simple linear regression for and what is a multiple linear regression for, right? So multiple linear regression is that if it is more than one independent values is present. we go for the multiple linear regression. So if there is only one dependent values and only one independent value, this is going to be the simple linear regression. The same way, here you are taking the formula of y is equal to mx plus c, right? So the equation of straight line. When I'm going for multiple linear regression, it is going to be you will be having for the independent values, different independent values, right? So one is going to be beta naught, beta 1, beta 2, and it goes on. Yes. And this is the multiple linear regression. So it is for estimating the relationship between the variable, between a dependent value and two or more independent values. So as I have already told you, the simple example for house price prediction. So when you are going with the house price prediction, you will be having the multiple factor that influence the price of a house or rent of a house, right? So all these independent values, that is x1, x2, x3. So x1, x2, x3 are the different independent features that we are taking. And y is going to be the predicted value. So if there is existent independent values present. So if we are talking about the multiple linear regression, you can say that this is going to be the statistical method that is going to establish the relationship between the dependent values and two or more independent values to be present, right? And this is the formula for finding out multiple linear regression. And what are the purpose of multiple linear regression is to do the prediction, explanation, and theory building. So it is completely of in the statistical perspective it has been given, right? Yes. And what is the variation? So total variation in y is this the complete figure. So you could see only a predictable variation. So when you are combining different independent values, okay, so some portion of it here you can see in the formula. So y predicted, which means that the target value is going to be the same thing, a intercept plus b1, bx1, b2, x2, and bn, xn, it goes on, plus error rate, the same thing, the error rate or what is the residual that has been given. So there could be, when you're talking about variation, there could be more unpredictable variation with a different combination of the independent values present. This is obvious. So when you, the predictable variation is providing by the combination of the independent values, only a portion of it we can do it. And the same thing, when you talk about this assumption of linear regression model, whatever we have seen from this is for the multiple linear regression as well. So it should be in linear form and fixed independent values and independent observation, which means that you are going to predefine how many independent values are there. So when you are talking about feature selection and what to say, if you are talking about the feature selection, so feature selection is that there would be, if there is 20 number of values are present, for example, if there is 20 features are present, okay, and we are not going to take all the 20 features. All these 20 independent features may not be needed for predicting a house, right? So there would be only very few is required for predicting the price of a house, right? So feature selection is nothing but you are going to pick up what are all the features that is only required for the given input, right? So feature selection and feature derivation, or else what to say, you are going to pick up whatever the required ones only. Okay, that is called as the feature selection. So what is the main purpose of taking up only the required ones? Why not we take the all the features together and work on it? Because if the size of your data set is huge, and if you are taking up all the unnecessary independent values, and it will have an impact in your prediction also. Okay, so what are all the unnecessary values or unwanted values are present, you can eliminate it and you can work on the particular part. So fixed independent value is nothing but, so whatever is required for the prediction of this part, you can take only those, that is feature selection is required. So out of all these feature selection, you can derive the features also, which means that For example, if there is date of birth is given in your data set, you can predict the age of a person, right? So if there is a feature derivation could be done, it can also be taken in that form, right? So this is fixed independent values, independent observation. So they represent the sample or specification of the model. So no omitted values, so which means that when you are defining in the model, you need to know what are all the features that has to be selected for the given things. And normality of the residuals or errors. Obviously, there will be some variation in your results and or deviation for the any of the given things. So if there is no best fit line that occurs for the given data set, we can able to change the values, and you are going to check with which is going to be the best fit line. The best fit line, so this is why your machine learning comes into play. So when you're talking about the biggest data set, where you can't predict the very first, whatever the observation is to be the perfect one for the given data set. Yes, the accuracy may vary if you are varying the inputs. So for all these things only we are going with the machine learning models, and normality of the residual or errors and equality of variations. So it is going to be the homogeneity in the residual variance that is we are taking, and multicollinearity. And then if there is an autocorrelation and if there is an outlier dispersion. So these are all the assumptions that is required for the multiple linear regression. So intercorrelation or collinearity. So you have, if it is collinear is nothing but how they are correlated. Yes, here we are taking two independent variables that are uncorrelated. So which means that we can uniquely partition the amount of variance in Y due to X and Y is, due to X1 and X2, and bias is avoided, which means that X1 and X2 are the two uncorrelated values. So this is why I have talk about this correlation in the very first slide. So what is the strength and the relationship that is existing between the different independent or different independent values? So if there is two variables present, we are going to check what is the correlation existing between those values. So if there is a strong correlation, or else if there is a positive correlation, negative correlation, if there is no correlation. So if there is no correlation, which means that the amount of variation in Y due to XY and X1 and X2 and the bias is going to be avoided. And if there is a small correlation between the independent variables, so if there is a small intercorrelation existing between the different variables, so it will not have a bigger bias in the beta coefficients, right? So whenever we are talking about the large intercorrelation, will the bias B coefficient for this reason, or the mathematical procedures are not needed. So we are going to check if there is a correlation existing between the variables. So if there exists, there could be a chance that it could be uncorrelated or intercorrelated or large intercorrelated. So small intercorrelations, large intercorrelation is that the amount of correlation that is existing, that is what is the value range of that. Okay, so if that is 0.1 to 0.5, 0.5 to 0.8, so you can see the how strong the relation goes on. So 0.1 is the relation that is existing, that is not much stronger. But if you are talking about 0.8, so we can say that that is going to be the stronger relationship only. Okay, so you are going to check if there is a intercorrelation that is existing between the variables and in what measures. So multi-correlation is that here you can say that the fat percentage, age, and the sex. So here it has been given as zeros and ones. So here this is going to be the model's summary. The same way what we have taken for simple correlation. So you are going to your ultimate aim is to minimize the sum of squared errors. So sum of squared errors, if we are talking about sum of squared errors, it should be always be minimal, because in order to obtain the best line. So here it has been given as df1 and df2, and this is going to be the degree of freedom. Here you are going to take 2 degrees of freedom in order to estimate it. And this is the model, and the final ANOVA test results has been provided. So with the regression analysis, what is the sum of square and what is the degree of freedom that has been taken, what is the mean square, and F is the values, right? So what is the test statistic value and what is the critical values that has been obtained. So if you are talking about the critical values and the test statistics values, so in order to accept or reject the null hypothesis, it is purely based on whether it is having the impact, which means that what is the outcome that we are expecting is that whether the fat percentage and age influences if it is the dependent value. So if okay. So this is going to be the dependent variable, the percentage of body fat related to the body. So this is going to be the dependent values. So here you can say that the predictors, which is going to be the constant, that is constant sex, and then the predictors, which is going to be the sex and the age. So what is the dependent values and what is the independent values present for the given data? So here it is going to be the dependent, and based on the age and the sex, whether the fat, you are going to regress the percentage of the fat related to the body. So this is going to be the dependent values of it. And any other discussions required on this? Can you give it in the chat box? And one thing I would like to say, so when you're talking about all these things, the basic steps we need to know about is statistics only. So today we have discussed the regression analysis in the statistical perspective, right? The same thing we are going to apply in the Python code. So that makes the difference between the data science, right? So we are going to implement all the mathematical formulas into a things. And when you're talking about the covariance, so here the correlation is strongly talked in this particular thing. And the same way, if you are talking about the covariance, yes, here we have talked about the direction also. There we will be talking about only the strength of the relationship existing between the variable, and we don't mind about the direction of the relationship, right? So that is called as the covariance. The same way, we just going to take the values just from -1 to +1. So if there is a covariance of -1, we can infer that it is going to be the strong positive. So sorry, strong negative. And perfect negative, perfect positive, positive, negative, and then no correlation exists. And next one is about the regression, what is the normal form. Okay, so always we have to make sure that what is to be your data EDA analysis is, first one, you are going to take about what is the size of your data. Yes. And you need to know what is the size of your data set. And after that, you need to learn about what is the columns present and what is how many number of features is present inside your data set and the indexing of it. And then what is you can take a sample of 5 to 10 rows, and you can analyze what is how your data set looks like, right? What are all and then later you need to know what are all the data types. Yes, what are all the data types present inside your data set. And it could be either numerical one or the categorical data, right? So if it is a numerical data or categorical data, so you need to know about the exact complete information about your data set. So if you are giving the data frame.info, it will be providing you the complete information. So how many not null values are present, what is the data type, and what is the memory, right? What is the size of your memory size of your data set? So it will be providing you all the things. What is the index values? So this will provide you the thing. And next one is description of your data set. It is very much important. When you are describing your data set, you need to know what is the 5-number summary, right? What is the minimum value of your particular feature? What is the maximum value of the particular feature? And what is the 25 percentile, 50 percentile, and 75 percentile of your data set, right? So when you're talking about all these things, when you are giving df.describe it, in general, it will be describing only the numerical steps. Yes, so it will be taking only the numerical data and it will be explaining only the numerical data about it. So what is the min max values, what is 25, 50, and 75 percentile of the data set. And then later you can move on to the next part. If you want to know about for the categorical data also, right? So if that is the case, we can go with the categorical steps. Yes, include is equal to all. It will take both the numerical and categorical data. It will tell you what is the frequency, what is the count. Yes, so it will be including all those things. What is the frequency, count, and the same thing. What is the 25, 50, and per. So what is the ultimate aim of knowing this is? So which could be the you can know about the outliers also. You should know about the outliers also. When you are converting all these into the box plot. Okay, so if it is in the box plot, you have to know what is the outliers present. Right, so you will be eliminating what are all the outlier values. And you can say that 50 percentile is the median value. Yes, so what is the middle value? That is the median value of your data, right? So this is the 50 percentage. So when you're talking about Q1, Q2, Q3, which means that Q1, it has 25 percentile of your data below the data, below Q1 and 75 above Q1. When you're talking about Q2, 50 percentage above, below Q2 and 50 percentage above Q2. When you're talking about Q3, 75 percentile of your data is below Q3 and 25 percentile is above Q3. So these are all the basic steps you should know. How to calculate the minimum value. Q1 minus 1.5 into IQR. What is an interquartile range? The difference between the Q3 and Q1, it is called as the interquartile range. Right? So if you are talking about the interquartile range, you should know in the IQR in order to eliminate the outlier value. So how we are going to eliminate the values that is lesser than the minimum value is Q1 minus IQR into Q1, right? So you will be eliminating the IQR value, sorry, minimum outlier in the lower fence and outliers in the upper fence. So these two things has to be eliminated in the same way. And the next step is to be, after eliminating all this, you are going to normalize, standardize your data set. So the formula that we are going to use it, that is the main thing, that is what to say, z is equal to mu minus x divided by sigma. So it is for the standardization. So standardization is nothing but you are going to eliminate the, you are going to standardize the values or normalize your values. So the range of values will be, the given range of values is between these two, right? So the values, if you want to compare the values of different things. So here you can see, right? So if you are taking about, don't mind about the, which is dependent or independent. If I have to compare the age and the fat, then you can see that the value ranges is from, it starts with 23, right? So 23 till 61. In the fat range, it is between 9 to 34 somewhere, right? So this has the different distribution of values. So when you are plotting all these things, it won't be, you cannot infer it properly. So we are going to normalize everything or standardize everything. So it will be in the particular range of values, and then we can able to plot it. So that is going to be the that is going to be the standardization. So when you are going to normalize your values, you can see that the ranges is, it takes the bell curve. Okay, so if it is taking the bell curve, you can see the mean, median, and mode values. All these values are nearby. So what happens if it is skewed? Either in two ways we can say it is to be skewed. Either it can be left skewed or right skewed. So in either ways, right? So if there occurs an left skew or right skew, you have to normalize your data, and then it has to be normally distributed, and then only you can feed into your data set. And apart from this, you are going to check what are all the null values present inside your data set. Okay, so if there is any null value, for example, if I'm giving you a Google form, okay, if I'm giving you the Google form, and you will be mainly, if I'm giving, this is the mandatory part. Okay, so you will be listening, sorry, you will be writing only what is the mandatory part, and all the other things you will be left as such. Which means that is not required, right? So that is not that much required. For example, I need your details. So your name, your registration number, or else you can go with your what is your area of interest. Okay. So if you are talking about the secondary mobile number, how many of us will give? So all these things will be you don't have data for that. So if there is any null values present inside your data, how to handle this null values? Either you can replace it with zeros or ones, or else you can go with dropping off rows and columns. If you opt dropping off rows or columns as an option, you can say that there is a missing of information, right? So in such cases, we don't opt for missing value calculations, right? So if we are taking up dropping of rows or columns, when the null values encountered, there is a loss of information, obviously. So you would be missing out some important values. So there could be a case that you can replace it with the dummy values, right? So either you can replace it with zeros or ones, or else in general, what we'll do is if it is a numerical value, we will be taking up with mean or median. And if it is a categorical value, we'll go to mode, right? So mean or median is nothing but, so here, this is the total, this is the total number of observations, sorry, number of observations by total number of observations by number of observations. And if you are taking the median value, we are going to fetch only the middle value of it, right? So if the number of values is odd, you are going to directly pick which is the, after rearranging in the ascending order, you are going to pick which is the middle element, and you are going to project it as a median. And if it is in the case of even values, you will be taking the middle two elements divided by 2, right? So this will be gives you the median. And mode is nothing but there is a frequent occurrence. So if how many what is the maximum occurrence of a particular value? So we will be replacing it with the value. So if it is the categorical value to be filled, we will be using that part. So overall, your workflow will be in this way. And next one is before going into any model, this is the pre-processing stages we will do, and feature selection. And feature selection, as I have told you that we will not take all the features, right? So dimensionality reduction is always required when it is an oversized. So we will be using some techniques like PCA, right? Principal component analysis, in order to convert into the multi-dimension into a one dimension, and in order to reduce the dimensional size, you will be doing either feature selection or feature derivation, or else if there is the same thing, right? Here, if you want to split this into two categories, so 6 here, zeros and ones. So you can split it into a separate category. For male or female, you can mention that as a different features. So that is of a one technique. So this is the feature selection and feature derivation. After doing all these things, you can implement using implement the regression model. So you are going to import from a scikit-learn or a sklearn, and you are going to implement the regression models, and then you are going to fit your data into the particular model. So after fitting it into a model, we are going to see what is the sum of square errors, right? So what is the what is the R square values? What is this? What is the coefficient? What is the slope value? So you will be obtaining all these things. So when your data when you're feeding your data, it could be either in the training data, you are going to whatever the data you are going to feed in the training is called as an observed values, right? So as a data set, I will be feeding it. So you will be dividing your data set into 70-30 or 80-20. Yes, 80 is for your training and 20 is for your testing. So in order to segregate all those things, you will be using the different methods also. Yes, you will be assigning the random values, or it could be using any of the techniques in order to fivefold crossout. So all these things, cross validation. So all these methods and techniques you can use for it, right? So after implementing all these things, you can move on to the next part, fitting into the model. Okay, so after training and testing data, and then you are going to fit into the model, and you are going to check for the test data. Yes, what is the observed value? What is the predicted value? So what is the best fit line? Yes, when you're talking about the best fit line, when I call that as a best fit line is all the data points should be nearby the particular best fit line that I have drawn. Yes, so all the data points should be nearby. If the data points are scattered, and then I will be keep on updating the different values. I will rerun it. Okay, so this is how multiple linear regression is implemented, and the outcome is update. So this is how the values get distributed. Any other things has to be discussed from your end, you can share. Any inputs you required other than this? Thanks for joining. Any questions from your side, you can raise.
Thank you, Maithili.
Thank you.
Just now I posted the feedback form in the chat box. Kindly take your moment and provide your feedback, students, and you will be counted as to receive the certificate. And we are going to share the certificate in the next week, like a 4 to 5 working days. Anybody have any queries, any doubts, you can go ahead and ask the trainer. Anybody have doubts? I think they don't have any doubts, might be. So we can wrap it up for today.
Okay, thank you.
Thank you.
Yeah, that decision. Thanks for
Yeah.
joining.
Thank you. Thank you. Okay. Napurna, you can end the session.